Hello, everyone. This is going to be a relatively quick video on scientific notation. Scientific notation is a standard way that we write really small or really large numbers in the scientific community, and it does take on this formula. Let me try to make this screen bigger. Oh, it's going to share the wrong screen. That's okay. So it's going to follow this formula, m times 10 to the n. M is going to be a number, and that number might be a whole number, like you see here, 4, or it might be one digit followed by a decimal and then other numbers. The key here is that when we're talking about M, this number that starts off the whole thing, you can only have one non-zero number in front of the decimal. The rest of the number will go behind the decimal. And this will make more sense in a second as I do some examples. But I need you to notice there's only one non-zero number, then a decimal, then the rest of the number. Okay? Because the same thing is happening up here with the 4. Because do we agree that 4 can also be written as 4.0? Okay, we don't have to put the 0.0 there, but I just want you to notice that the setup is the same. One non-zero number followed by the remaining digits. Okay, then we have the times. You'll always have 10 because it's written as a base of 10, and then a digit. And the exponent here can be either positive or negative, and we'll work through how you determine which it should be. So let's just skip down here to the example. We want to write 54,321 in scientific notation. So what we're going to have to do is find the first non-zero number. And that is going to be the 5. So we can only have one non-zero number and then the decimal. So 5 comes first. So we're going to write point and then everything else. 4, 3, 2, 1. Okay? Because remember, you can only have one number in front of that decimal and it cannot be a 0. So we've written all the digits out. So then now we write the times 10, and we need to figure out what that exponent is. And how you do that is you figure out how many places you would need to move the decimal to get back to that original number. Okay? So because here's how I think about it. Scientific notation dictates I put that decimal right here after the 5. But where does the decimal want to be? We'll go back and look at your original number, 54,321. Do we agree that's the same as writing 0.0? So the decimal wants to be after that 1. So what do we have to do to the decimal in scientific notation to get it to where it wants to be, which is after the 1? We need to move 1, 2, 3, 4 places to the right. So that exponent is going to be a 4 because we've moved it 4 places. Now, to determine if the exponent should be positive or negative, that depends on the direction. The exponent is going to be positive if we moved our decimal to the right. The exponent is negative if we had to move our decimal to the left. So because it started here after the 5 and we moved it 1, 2, 3, 4 places to the right to get it behind the 1, which is where it wanted to be, our exponent remains positive. Okay, so you can see right down here is the answer. And so your exponent is always going to be positive if the number is large, it's above 1. Okay, and 54,321 is a big number. So our exponent needs to be positive. In the second example, the exponent is going to be negative because look at the number we're working with here, right? It's 0.002, which is 2/100ths. So it's a fraction. So that is the same as saying 2 out of 100 or 2/100ths. So if we want to write this number in scientific notation, we're going to take the same steps. We have to find the first non-zero number. So we can't use that because that's a 0. Can't use that. It's a 0. So 2 is going to be our first non-zero number. We plant our decimal because it has to be there. And you'll notice there's nothing else after the 2. So we're just going to go ahead and write a 0 there. When I'm teaching, I like to write 2.0. You do not have to. You could just put a 2 there, okay? And so now we're going to do the next part, which is times 10 to the something. So now we have to figure out what is that exponent. So remember how we do that is we say, okay, scientific notation is dictating that I put the decimal after the 2, but that's not actually where it wants to be, right? It wants to be over here, looking back at our original number. So I'm going to put my pen where scientific notation says the decimal has to be, which is after this 2. And how do I get it back to where it wants to be? I'm going to have to go 1, 2 places to the left. So because it moved 2 places, I write that as my exponent. But because it moved to the left, I have to make that exponent a negative. So the positive or negative is looking at which direction we had to move, and the number is telling us how many spaces we moved in that direction. Okay, so you would write it as 2 times 10 to the negative 2. All right, y'all, that's where I'm going to end this video, but I'm going to make another one that walks through all the practice examples on the next slide. So as always, if you have any questions, please don't hesitate to reach out.